So this is going to be a full tutorial from beginning to end for setting up a oil spill on land module using Hydronia's OilFlow2D. And right now we have QGIS open. We're going to go ahead and create a new project from scratch. And I could do that by going here to the plugins toolbar. And here we have the OilFlow2D plugin. I'm going to click on this first icon here to create a new project. As you can see, all the layers are selected by default. We're going to go ahead and select none. The only layer I'm going to add for now is the source sink layer. I'm going to change the projection to the one we're going to use for this tutorial. It's 2202. And then I'm going to set a project directory with one that I've already created. So now we have our layers set up here. And we're going to go ahead and import the digital elevation model that we need for this project. So I'm going to go into here to this folder. I already have it ready. I'm just going to drag and drop it. This is a trick. Just drag and drop it here into the layers panel. Then I'm going to bring this all the way down. I'm going to go ahead and change this styling to hillshade. And now we have the digital elevation model, but we don't really know where we are right now. So I'm going to go ahead and load up a map. And this is a plugin that you can download and install. It's called Quick Map Services. I'm going to go ahead and let's just use Google. Okay, so we've got our map loaded and we've got our digital elevation model here. And we need to set up first our area of focus. We're going to use our domain outline to establish where this model is going to run computation. So the first thing I need to do is make sure I have the domain outline layer highlighted, click the pencil icon. That puts this layer in edit mode. Then I'm going to add a polygon. And now by left clicking, I'm going to put down points and I'm going to draw the area that I want to run the model in. So I'm just left clicking here. I'm going to avoid going outside of the DEM here. And to close this polygon, I'm going to right click. Now a dialog box comes out. It wants to know a cell size. I'm going to give this 10 meters. So each individual cell is going to have 10 meters of size. So now we have our domain outline. I want to make this line a little bigger, a little thicker rather. So here on this layer styling panel, you can get to this by going to View, Panels, and then checking this box here for layer styling. I find it very helpful. And here I'm going to go to stroke width. I'm going to set that to 1 just to make it thicker. You can change the color as well. You can fill it. You can just keep it empty. I like to just keep this the way it is. Then I'm just going to go ahead and save my changes here. Save layer edits. Then I'm going to click the pencil icon to take it out of edit mode. And that's our domain outline. So when we generate the triangular mesh, it's going to stay within these boundaries. So the next thing I'm going to do is set up a boundary condition at the bottom here. This needs to be set up on the domain bound outline itself. I'm going to put this in edit mode. Again, click the polygon tool. I'm going to draw a square around this bottom edge by left clicking each point. I'm going to draw this rectangle. And then I'm going to close it by right clicking. This is going to be a free outflow boundary condition. We're just going to let whatever fluids that reach down here just go right out of the model. We'll leave the rest alone. I'm going to get out of edit mode. I'm going to save this first. Okay, so now we have our boundary condition. Let's go ahead. We can set up a simple manning layer just to give the terrain roughness. And typically you want to give terrain roughness depending on the terrain, obviously. Here we have, if we turn off the DM, you can see that's a mix of urban and commercial area here. And then some mountainous or hilly area. So we're going to just draw a simple polygon for the manning. I'm going to go ahead and select the manning end layer, click at it, click on the add polygon button, and since we're just going to keep things simple, I'm going to just draw a square around the entire domain. It doesn't have to be inside of the DM. And then I'm going to right click to close. We're going to put 0.003. And now we have a manning end layer. I'm going to save it and turn off edit mode. Now we need to set up a source. So this is where our oil spill is going to occur. To do this, I'm going to go ahead and edit, click on the add point feature. I'm going to drop a point right here on the hillside, and we'll put it up here. I'm going to leave the name source 1. We're going to select as a source sink type discharge versus time. Now I already have a source sink file in there. And then click OK. Now we have our source. We're going to save this, close. The last thing we're going to do is we're going to generate our tri-mesh. We could do this one of two ways. I could just generate a tri-mesh that'll create the adapted triangular mesh, but this will not have any elevation data embedded. That means that upon export, when I export this to the model, the export process is going to have to embed that elevation data into the export. But the other way to do this is to embed it in the mesh itself. So I'm going to select generate tri-mesh with elevations. This is the correct file, the DEM layer. Click OK. And now QGIS will create a mesh for us. And you can see we have our mesh. And now we're going to go ahead and export to the model. I'm going to select this export button here, the drop down, export hydrodynamic OilFlow2D. We're going to give this a name. I'm just going to call it spill. And we're going to click OK. And now the QGIS opens the Hydronia dip program with the default settings. Right now we have a sources sync file. We have the component enabled, and then a default, simulation time, the output interval, and an interval for components. We're going to go ahead and just alter this a little bit. I'll leave the simulation time to 2 hours. And now I'm going to select the oil spill on land module. And once we do that, we need to set up a few things here in the module section. So over here in the module section, I'm going to click on oil spill on land. And right now, we have the heat transfer model on. I'm going to select the basic model. And we're going to leave all the default values. I'm going to save this OilP file. I'll give it that name. I'm going to go back to control data. I'm going to save this DAT file as oilspill.dat. It's the name of the project. And then I'm going to run OilFlow2D. I don't need to save changes because I just saved them. Now we have the model running. You have a little preview here of the oil moving. So that's finished. It says here lapse time. It's completed because it says simulation completed. And I'm going to click close. And this generates the maximums file at the very end. And it will close automatically, but I'll close it myself. I'm going to cancel, or I'll just press no here. If I press no, this will close the dip program. If I press cancel, it will not close it. So now I'm back in QGIS. I want to see the results of that run. So I'm going to turn off this tri-mesh layer. Then I'm going to go to the toolbar and select the output button, drop down menu. And here we have a few options. Right now I just want a simple depth output. So I'm going to go to a maximum result maps. This opens up the dialog box to select the maximum file value. By default, it will search the main folder of the project. And this is the file it's looking for. This underscore cells underscore max dot text out. It'll have the project name underscore cells underscore max. And then here we have a few options. I just wanted to see the maximum depth. We'll leave this as cell maps. You have the option of creating rasters as well and setting the resolution. So now we have the oil spill. Unfortunately, this oil spill using the basic model, it flows kind of like water. So it just kind of goes everywhere. And it even got out here to the domain boundary, which we didn't put an outflow here. So I can correct that by going here to boundary conditions, clicking edit. And I'm going to click on this vertex tool here. So what I'm going to do is I'm just going to expand my boundaries. Alright, so once I've got it how I want, I'll just save it and disable edit mode. So I will have to export any changes that I've made here. So we have this very simple output. It shows you where the path of the oil goes. As you can see, it goes in between the streets. It takes into account all the elevation data and goes where it needs to go. But this is too simple. So let's go ahead and turn on the heat transfer module. I'm going to go ahead and export the project again. I'm going to disable this output. I'm going to enable my tri-mesh. Since I haven't made any changes to the mesh, I've only changed the domain out, the boundary condition. So this I could just export as is, making sure all of my layers are selected that I need. Export from the plugin menu, and we're just going to leave everything the same. This will open up the dip programming again. So we're going to enable the heat transfer option on this model, because what we did before with the basic model does not really simulate how different conditions would affect the oil. The oil temperature is pretty high usually when it comes out from the spill site, and then the ambient temperature will bring that temperature down typically, and oil behaves differently at different temperatures. The viscosity changes, the yield stress changes, and the oil can slow down significantly. So by enabling the heat transfer model, we can account for different things, such as the wind velocity, the relative humidity, the temperature, and the solar radiation. All of these variables can affect how the oil changes, the oil properties change rather, over time. These are contained within a file that we have named solarrad.txt. As you can see, it's already loaded here. And an example of that file is basically this table, but in text format. I'll go ahead and open it. It's in the project directory. It's got 249 lines, and these are the columns of data. You can see the columns here. Okay. So enabling heat transfer opens up this. You could change the flow resistance relation algorithm here. Leave this a quadratic. We can set an initial oil temperature and a heat capacity. We can have a density formulation here, viscosity formulation, or we can provide a table. In this case, we're going to use a formulation. Here we provided a table, and it's coming from a text file called ys_dummy file. And this is the yield stress relationship to temperature. So as the ambient temperature changes based on your solar radiation file, So here your temperature is 25 degrees Celsius, 29, 36. This temperature will start to drop the initial outflow temperature of the oil. And then based on that, the yield stress values will change based on this table. Now, something else we need to do is make sure our source file, we put temperatures on them. I've already made the changes to this file, but if I go back to the source file and open it, you see I added a third column, and I set the temperature of the source to 50 degrees Celsius for each line, and I added an additional line here. Okay. So once I did that, and once I've saved or opened this OilP file, I'm going to save it. I'm going to rename, I'm going to keep the name of the project, OilSpill.OilP, save it. I'm going to go back to control data, make sure everything is correct here. It looks like it is. And then I'm going to run the model again. And now we should see different results. As you can see, the output is different this time because the heat transfer model is running. I'm going to go ahead and close. Close this, and we're done with the model. So now, I'll go ahead and remove this layer here. So now that we run the heat transfer model, we can have different outputs that are useful for knowing, for instance, the temperature of the oil along the spill, the viscosity of the oil, the density. We can access these by going to the Results versus Time button and clicking on Oil Properties versus Time Maps. So we're going to click here on this button. I'm going to click on the Out Files. And now I have 4 different options, right? And this is each option, I can have it for each output time, each output interval. So I can get a map of the oil temperature at 30 minutes runtime. I can get an output of the density at 30 minutes, the viscosity, and the yield stress. This is just an example. We'll load them all. When that finishes, I'll turn off the tri-mesh layer. And I've got all these outputs stacked on each other. So let's go through them one by one. In order to make this a little easier, you can turn on the labels for the individual cells. But for now, I'll just use the legend. So we have a lot of red here. This means that the temperature here was between 45 and 49 degrees Celsius, according to the legend there. And it stayed that way until it got here. And this seems to be where it stopped at this point. Well, it's not stopped. This was at 30 minutes, so we'd have to look at the result for the final time period or time step. Here we have oil density. Viscosity, and yield stress. As the yield stress goes up, which it's not, except in certain areas here in the edges, the yield stress being at this range, the oil will continue to flow. That should be different over time. So I'm going to go ahead, if we want to see that, I can create an animation. I'm going to click on this animation panel button. Oh, we got to save our project. Very important. So let's click Save here. And we're going to go to that project directory. Okay, very important. So I enable the panel, and I'm going to select what layer I want to animate. And a very interesting one for me is typically the yield stress. I'm going to click Add Layer. It goes ahead, adds it. Now you see you have this animation layer, but it's under everything. In order to see it, we need to put it above the DEM. Turn off this tri-mesh again. And go back here. Make sure that this is selected and it's checked. Click on here. And then I can just play the animation. And as you can see, I'm going to open up the legend here. It should start to change color as the oil goes down in temperature. Now by the source, the oil is already dropping in temperature. Now we can see the effect of this over a longer period of time. 2 hours is very short. So we can go ahead and change that by rerunning the model and changing the simulation time. But if I'm going to run the model for extended amount of times, I would like to use the help of the GPU. So let's get rid of this animation. We're going to get rid of all of our little outputs because we're going to take this model a little more seriously. I'm going to remove these layers. I'm going to save my project. I'm going to open up the dip. And this time, I'm going to set the simulation time to 24 hours. And I'm going to turn on, under model selection, OilFlow2D GPU. This automatically detected my video card. And I'm going to save this and run it again. So the simulation finished. I'm going to go ahead and close this. This is finished as well. Click no. Alright, so we're back in QGIS. I'm going to go ahead and pull out that animation again for yield stress, oil land yield stress. Okay, now we have our animation. Now we should see the oil temperature dropping over time as the spill stops. And we'll see something interesting happen towards the end of the model. Because since this is a 24-hour run, it's going to take into account the changes of temperature during the day and night cycle. So the nighttime, as you can see, the oil is cooling down. most likely this is occurring in the middle of the night, and then later down the line, nearing the morning and noon time, the temperature will go higher and the yield stress will lower and allow the oil to flow some more. See, right now the yield stress is lowering again. This is the effect of the temperatures. I'm going to have to move this a little quicker. I upped the speed of the animation to 3 frames per second. So this is getting into I believe the afternoon, and now the oil became less viscous, and it enabled it to move a little further down till finally it cools down again. So when you model for temperature, ambient temperature, oil temperature, density, viscosity, yield stress, you get very different results. And you can show that inverse relationship by creating these animations. You can even create one for temperature, and it should be an inverse relationship there. Let's go ahead and add that temperature animation. Alright, so we have it loaded here. So let's just go ahead and run this animation. I'll leave the speed at 3 so it'll go a little quicker. You can see the colors are not that dark color here at this extreme end of the legend. You see the temperature's already dropping. Looks like we're in the 25 degrees to 32 degrees Celsius range. And as it starts to get hotter, we should see the shades get darker. Right around now, you see that these areas are darkening and they've gone up in temperature. And with that increase in temperature, oil should start moving again. Now we could pause the animation here. Let's put it back to where it was, right around this point. So here I have layered one on top of the other, the yield stress and the oil and land temperature animations, right around the 18-hour mark, which should be the late afternoon, basically when most of the heat is present. And as you can see, yield stress is low around this time. And if I turn off the yield stress and let the oil and land temperature come up, you can see that the oil and land temperature is also up right? So yield stress down, temperature up. And you can clearly see that relationship. If I move the time steps, let's say for temperature, let's move it up to 20 hours. And we'll put the yield stress at 20 hours. As I enable and disable the layers, you'll see yield stress is very low right now. And the temperature is up. And this is what caused this oil to move a little further, even though there was no more oil coming out of the source. So there you have it. It's just a very quick and easy comparison to see the difference between running a basic model and a heat transfer model for oil flow, oil on land spills. So that about wraps up this short tutorial on getting started with the oil on land modules for OilFlow2D. Thank you very much for watching this, and please reach out to us at support@hydronia.com if you have any questions. Thank you.